Hello students. In today's session, I will discuss about the enzymes. This is the last part of the topic biomolecules. Let us discuss one by one the properties of enzymes. Number one, enzymes are made up of proteins. But remember, all proteins are not enzymes. Second property, enzymes are very specific in their action. They have active sites which are stimulated in presence of substrates. So every enzyme gets activated in presence of substrate and induced to change and allow substrate to fit into it. At optimum temperature and pH, enzyme activity will continue and it will see that substrate has to convert it into product using less energy and in less time. So these enzymes which act as a catalyst, first it starts the reaction, second it accelerates the reaction, then it maintains the pace of the reaction, and then it inhibits the reaction once the products are generated. The enzymes are inhibited at the extreme temperatures. Enzymes undergo inactivated state at the lower temperature, same way for the pH. So change in pH, change in temperature and obviously change in pressure may deactivate the enzyme action on the substrate. The enzymes undergo denaturation when they are exposed to heat. Once the enzyme undergo denaturation, renaturation is impossible. All enzyme catalyzed reactions are reversible. The enzymes are hence called as biocatalyst. Without enzyme, biochemical reactions for which we call metabolism, anabolism, catabolism and amphibolism unable to run. So, the living status of the cell is due to a catalyst enzymes. The enzyme action on the substrate is well explained by lock and key concept and induced fit hypothesis. As per lock and key concept, which is very old theory, they say that for every substrate there is a specific enzyme, like for every clock, whether to lock it or unlock it, specific key is required. We cannot use any key to unlock the locked clock. Thus, any substrate and any enzyme is impossible. So, a specific enzyme has to act on a specific substrate, then only we can expect the product. As per induced fit hypothesis, this is well accepted hypothesis to explain the enzyme action on the substrate. Consider these are the enzymes. Look at my fingers. They don't have a constant shape. Okay, this right hand finger is a substrate. Now, the enzymes are activated due to their active sites. They will take a particular shape, right? As the substrate approaches, the enzyme is induced to remain in active state to form ES complex. So thus, enzyme is induced with the help of active sites so that the substrate will fit into it. This ES complex, when it is generated, it is considered as the transitional state of the reaction. In transitional state, the energy used by the reaction is very less. Because of the transition state, the other substrates who are still without any enzyme support, they are raised at the higher level. So kinetics of the enzyme action, that is velocity of the enzyme or the rate of the enzyme action, increases slowly as the substrate concentration goes on increasing. Once the substrates and the enzymes, they enter in a transition state showing ES complexes, the enzyme velocity try to attain the stability. As the product generation begins, substrate concentration decreases and product concentration increases. This will maintain the velocity of the enzyme action. As per Maclean-Menten constant Kmax, we call it as Vmax. Okay, it is discussed in a separate part, but as per this Maclean-Menten's constant, as long as substrate concentration is higher and if enzymes are available, the velocity of the enzyme action increases. This we call enzyme kinetics, goes on increasing. Once the 50% of the substrates are already in a binding site of the enzyme, both are together, entered in transition state, okay, that is called as Vmax. Once it reaches that level, further enzyme kinetics unable to increase, it starts declining or it becomes steady. This gives a rectangular hyperbola. Considering temperature during enzyme action, as substrates are available, enzymes are available, rate of the reaction and rate of the enzyme action goes on increasing up to a certain temperature. After that, enzyme deactivate. Further enzyme action we cannot. So this gives a straight line. Thus, the effect of pH, effect of temperature, effect of pressure can be studied by various graphs. Okay, but believe that at particular concentration of the substrate, optimum pH and optimum temperature, enzyme kinetics will increase. Beyond that, it unable to sustain, it try to become steady. Thus, enzymes as a catalyst, they can bring the transfer, they can change the molecular composition, they will bring the substrate to the product by changing its physical form as well as chemical form. Enzyme will help the substrate to break the bonds. Enzyme will help the substrate to form the bonds. So according to the action of enzymes, we classify them into 6 groups. Enzyme oxidoreductase will help in regulating or catalyzing oxidation and reduction processes. This we call redox reactions. Enzyme isomerase will catalyze formation of isomers by bringing molecular change in the molecule. Enzyme transferase will bring the transfer of the molecule. Enzyme hydrolase will catalyze addition of the water molecules in breaking the bonds. Enzyme lysis will help in cutting the bonds or without adding an water molecule. Enzyme ligases will help in ligation or stitching the two components together by developing chemical bonds. Thus, oxidoreductase, transferase, isomerase, hydrolase, lyase and ligases. You observe here in the name the suffix ase is added. Most of the enzymes are named based on the substrate on which they will act, and they will add the suffix ase. So wherever we find ase as a suffix, consider that it is an enzyme acting on a particular substrate. For example, lactase will act on lactose, galactase will act on galactose, protease will act on proteins. Like this, the enzyme names are given. When the suffix lytic is added, it shows the action of the enzyme. For example, proteolytic. It catabolizes proteins and degrades them into peptones, peptides, etc. Amylytic means it is a group of enzymes will bring a catabolic reactions among the carbohydrates by which polysaccharides degraded to oligo, oligo to disaccharide, disaccharides to monosaccharides. Thus, in enzyme topic, you should know features of enzymes, you should know factors affecting enzymes, you should know what exactly activation energy is, the graph showing the rate of enzyme activity and enzyme kinetics along with the substrate concentration and product formation, and lastly the classification of enzymes. With this, before I conclude, okay, remember, if a paper and matchstick is there and if you want to burn the paper, you just lighten the matchstick, the burning process will begin. But if you want to reduce the time and efficiency of the burning process, you just add a corrosive like kerosene or petrol. With higher speed, the burning process will continue. So here kerosene or a petrol act as a catalyst. Thus, to carry out any reactions in the cell wisely utilizes enzymes in short time using less energy. They can complete the biochemical reactions. So believe the enzymes are the biocatalyst in the living system. With this, I'll conclude this session. Thank you very much.